How is a thunderstorm formed? Thunderstorms are ferocious, brief weather disturbances that nearly always include lightning, thunder, thick clouds, significant amounts of rain or hail, and strong gusty winds. Layers of warm, moist air rise in a strong updraft to cooler areas of the atmosphere, whereupon thunderstorms form. At that location, the updraft's moisture condenses to create imposing cumulonimbus clouds and, eventually, precipitation. Cooled air columns then descend to the ground and are met by powerful downdrafts and horizontal winds. At the same time, electrical charges build up on ice and water droplets that are part of clouds. When the electric charge that has collected is sufficiently high, lightning discharges happen. When lightning strikes, it instantly and intensely warms the surrounding air, creating shock waves that sound like thunderclaps and rolls, vortices of air that are constantly spinning and powerful enough to create tornadoes occasionally accompany heavy thunderstorms. Nearly all parts of the planet are known to have thunderstorms, while they are uncommon in the polar regions and seldom in latitudes higher than 50 degrees north and 50 degrees south. Therefore, the world's temperate and tropical regions are more likely to see thunderstorms. The Florida Peninsula, the Gulf Coast, and the highlands of New Mexico in the United States experience an average of 20 to 60 thunderstorm days per year. According to estimates, there are roughly 1,800 thunderstorms active at any given time around the planet. This page discusses the meteorology of thunderstorms, including their development, structure, and dispersion, as well as their electrification, example, the generation of lightning and thunder. See tornado for detailed coverage of related phenomena not included in this article. Thunderstorm formation and structure. Atmosphere's vertical motion. Wind and descending air disturbances that are most intense and fleeting. This trend applies to thunderstorms as well. A thunderstorm is said to form when the atmosphere becomes unstable to vertical motion, to use technical language. Any time relatively warm, light air is covered by cooler, heavier air, such an instability may develop. In these circumstances, the cooler air has a tendency to descend, pushing the warmer air higher. A strong current of rising air will be created if a significant enough volume of air rises. When water condenses and forms clouds in an updraft, latent heat energy is released, which further fuels the upward air motion and heightens instability. Rising parcels of warm air in an unstable environment accelerate through their cooler surroundings because they have a lower density and are more buoyant once upward air motions are started. This movement can create a convection pattern where warm, moist air is moved higher while cooler, dry air is moved downward. Cells are regions of the atmosphere with rather strong vertical motion, and deep cells are those that carry air to the upper troposphere, the lowest layer of the atmosphere. Deep moist convection cells coalesce and mix to form thunderstorms, which eventually result in precipitation, lightning, and thunder. Numerous mechanisms exist for starting upward motions in the atmosphere. The heating of a terrestrial surface and the surrounding air layers by sunlight is a typical mechanism. If the surface is sufficiently heated, the air will become unstable because the lowest layers' temperatures will rise more quickly than those of the upper layers. The majority of thunderstorms originate over land as opposed to the ocean because of how quickly the ground can heat up. A heated ocean surface or layers of warm air might cause instability when layers of chilly air are warmed from below after passing over them. Mountains can also cause an upward atmospheric motion because they operate as topographic barriers that push the wind upward. When the sun heats the mountain surfaces, they also become powerful sources of heat and instability. Types of thunderstorms. There was a time when thunderstorms were categorized based on where they originated, such as local, frontal, orographic, or mountain-started thunderstorms. Today, it is increasingly customary to categorize storms based on their individual characteristics, which are heavily influenced by the meteorological context in which the storms originate. According to the National Weather Service of the United States, a severe thunderstorm is any storm that generates a tornado, winds that reach 94 km per hour or more, or hail that is at least 2.5 centimeters in diameter. Isolated thunderstorms. Where there are mild winds that do not fluctuate significantly with altitude and where there is a lot of moisture at low and middle levels of the atmosphere, that is, from close to the ground up to 10,000 meters in altitude, isolated thunderstorms are more likely to form. Air mass or local thunderstorms are other names for these storms. They have a structure that is primarily vertical, are not very long-lived, and typically do not create severe weather on the ground. Such storms are made up of one or more convective cells, each of which has a distinct life cycle, according to data from aircraft and radar. The air moves largely upward early in a cell's growth, not as a continuous, uniform stream but rather as one made up of a number of ascending eddies. As the cell expands, cloud and precipitation particles develop and increase. A downdraft begins when the weight of water and ice that has accumulated becomes too great. When cloud particles evaporate and cool the air, which is almost the opposite of what happens in an updraft, the downward motion is accelerated. The cell has both updrafts and downdrafts when it has reached maturity. As precipitation emanates from the cloud, the downdraft gradually diffuses throughout the cell and loses strength. In isolated thunderstorms, there may be one or more convective cells that are at various phases of development. A multiple-cell thunderstorm frequently develops when a storm's downdrafts and related outflows stimulate new convective cells nearby. Localized, isolated thunderstorms are frequently triggered by solar heating. When surface temperatures are at their peak, late afternoon and early evening are when these storms tend to occur. Mesoscale convective systems and multiple-cell thunderstorms. Squall lines, supercell storms, or coordinated multiple-cell storms are typically what cause violent weather on the ground. All of these are frequently linked to a mesoscale disturbance, which is a meteorological system with a horizontal extent between 10 and 1,000 kilometers. Multiple updrafts and downdrafts occur simultaneously in multiple-cell storms. They appear as groups of cells moving collectively at different phases of development. One cell in the cluster takes the lead for a while before waning, and another cell then continues the cycle. Squall lines are organized lines of thunderstorms that produce a single, continuous gust front or the storm's outflow from its downdraft. The powerful updraft and downdraft that characterize supercell storms are covered in more detail below. Thunderstorms can occasionally form over an area with a diameter of hundreds of kilometers when a mesoscale meteorological disturbance develops. These disturbances include low-pressure troughs at higher altitudes of the atmosphere and frontal wave cyclones, which form from waves on fronts dividing warm and cool air masses. Afterwards, a mesoscale convective system of storms forms, MCS. MCSs typically coexist with severe multiple-cell and supercell thunderstorms. These systems frequently produce precipitation from stratiform clouds as well as convective clouds, cloud layers with a large horizontal extent. Remains of older cells with a relatively low vertical velocity, i.e., with little convection occurring, are the main cause of stratiform precipitation. A cold front can produce thunderstorms when it enters damp, unstable air. Sometimes, tens to hundreds of kilometers before a cold front, squall lines form in the warm air mass. Prefrontal storms often align more or less parallel to the front, which suggests that the front's atmospheric disturbances are what cause them to form. Severe thunderstorms frequently develop in the central United States during the spring when chilly westerly winds at intermediate altitudes of between 3,000 and 10,000 meters pass over warm and humid surface air moving northward from the Gulf of Mexico. The wide region of instability that results causes MCSs to last for several hours or even days. Near the equator, the northeast and southeast trade winds collide in the tropics, creating the intertropical convergence zone, which is known for its wet and unstable air. The ITCZ is home to a lot of thunderstorms and MCSs, which are crucial for transferring heat to higher altitudes and higher levels of the atmosphere. Thank you for watching. View more our channel videos.